Hey, welcome to Physics 40 Lab. Today I am going to show you how to analyze data in Logger Pro. So first of all, you should have downloaded Logger Pro. Looks like this. Here you have data and you have the place to do the plots. And then if you go to the, let me share my, if you go to the lab instructions for the pre-lab or the lab, you can go get your data. The Logger profiles have an extension CMBL, and when you click on it, it will download, and then you can open it. I would download them all to your computer and then launch it from your computer is what I would do. So then it should be in, there it is. So it loads up into Logger Pro. The other way you could do it is you could click on the folder up in the left-hand corner like that, and then you can go, say for example, you can go grab your data here and it'll insert it in. So if you watch the video, hopefully you've watched the video showing how the data is collected that Kristen showed. In fact, let me just, I'm gonna go back and show you that in case you haven't seen it. So it's a cute little video that Kristen made, and here it is. This is her making the data. See, she's dropping the ball underneath the motion detector, and then Logger Pro makes the data. Okay, so then she did that 50 times. Thank you very much, Kristen. And what's so cool about it is you can play them like an animation. So many of you have used Logger Pro in chemistry. It's an industry standard, and so it's really good to learn it. So I recommend that you go onto the Vernier website and learn as much as you can on your own, or you can just learn it in lab. But you get the actual data off to the left here. You can, I encourage you to click on everything. And so you can see, here's all the data. You can resize all the windows. We're not really using this data this time. We're going to be using the position, the velocity, and the acceleration plots. So I think the graphical interface is pretty intuitive, but, click on everything for this pre-lab, so that you can figure out what stuff does. But here's what's really cool is you can go to replay under analyze and watch. So you just go start and this is the actual data collection that Kristen made. And you can even go slower. You can set the time and make it half time. I think it goes slower. And then it goes slower so you can watch it, which is super fun. So what you're doing today is, 75% of the actual lab. The part you're not doing is dropping the ball and setting up the equipment, which is fun. So now this is the position versus time and the velocity versus time and the acceleration. One thing you want to do is make sure all the axes are lined up. So, and you can see when you move the cursor around that in the lower left-hand corner, you're seeing an ordered pair for the coordinate. So I'm going to just, let's see, let me just change this to 3. So you can click on, okay, I want these to have the same time. And this one, the way it's made, they're kind of not lined up. You want them lined up. So I'm kind of eyeballing it, which is not the most precise, but this lab is really about learning how to use Logger Pro and doing the analysis. So it's okay. So I dragged that to line up the ones. And you can see this is the bounce, which is groovy. That's the little bounce. So the way to do the curve fits is you just highlight. So click on the position versus time. And there's other ways of doing this that are probably smarter too. I'm going to hold the shift key and click on each one so they're all highlighted. Is that the word? And I want to make sure the data that I grab, notice how it, look, it sweeps it out. I'm clicking and holding and dragging, okay? I don't want to go into the bounce. Now, you could see that the regions where the data is for the position versus time, velocity, and acceleration are not the same. You could see like in the position versus time that this is where the bounce starts, this peak, well, the bounce looks like it started earlier for both the velocity and the acceleration plots, and that's because the motion detector is measuring position. So, and then velocity and acceleration are calculated. And since it's done through a process of interpolation, you're losing a little bit of your endpoints. So you want to make sure you're grabbing data that is not in the bounce for everybody. So I also want to make sure that the data I grab is not while I'm holding the ball. So you have to have, like, this is still just a fraction of a second, and Logger Pro, as long as the resolution is pretty high, like it's taking data, you can get away with just a little snippet. So I'm going to use this little snippet here. And so it's consistent throughout I might have to shift on the acceleration because notice it's going into the bounce, but this looks pretty good it's in the quadratic region of the position versus time plot. And then again, look at what's happening in the corner. You can see the coordinates, the delta t and the delta x, which is kind of fun. So these are the fits up here, and you can just hold the cursor and see what each one is. You can do the examine tool, tangent, statistics, which we'll be using for the acceleration versus time. You could do an integral, or this is just general curve fit. So you click on this and you get a bunch of options. So it shows you the data. You get a bunch of options. We want quadratic for the position versus time, and you do try fit. These are the fits. Now move it out of the way. So here's the equation. This is discussed in detail in the lab instructions. So I just want to show you how to do the curve fits and not make you watch a long video. So, but I'll use this fit here, AT squared plus BT plus C, and compare that to the given kinematic equations for constant acceleration to extract off the value of G from the coefficient of the T squared term. And so I'm going to use this A right here. 4.308. We don't use the uncertainty. We're going to determine uncertainty from average deviation. So we don't need the uncertainty in the individual measure. You could use it. Now I'm going to click on the VT graph, and this is a linear function. So I'm going to do the linear fit. And in this case, the acceleration is found from the slope. So I got 9.586 meters per second squared. Not bad. And then for the acceleration plot, so you have to click on the plot in order to do the fit, because if I click on the wrong plot, I'll get the wrong fit. So we'll use statistics for that. I forget which one is statistics. Oh, there it is. So I just hold it on. And then for the statistics, we're going to use 8.33. We use the mean, not the median, but the mean. The mean is the average. So notice they're not the same either. The values are not the same. So for this, I'm going to multiply that by 2 and I'll get 8.6. And then this was way better, I don't know why, 9.586 and then 8.33. So we're going to find the acceleration due to gravity by comparing the curve fits or the fits done by Logger Pro and compare it to the accepted kinematic equations for constant acceleration. And that is how we will find our value of little g. Thank you for listening.